Thank you, Thibaut. Can everybody hear me? Okay. Well, I appreciate it very much. I'm sorry I can't be there with you today. A lot of concern about what we're going to talk about today, of course, the weather. We already have about 2 feet of snow in the northern California mountains, and getting back home might have been quite difficult. So my talk today is going to look at the state of the climate. We are going to talk about what 2016 brought to us from a global to a national to a regional perspective, talk about some of the reasons why, look at current conditions and what's driving the changes that we have seen recently, and then look at a summary of all that and how it ties into the vintage 2017 forecast. So to start with, I would like to just kind of get where we are right now in terms of our 2016 perspective. The data just released today, both through NOAA, NASA, and some other national agencies across the world, showing that 2016 was the warmest year on record, highest since we've had good records in 1880, and measuring 1.7 degrees above average totally across the globe, but land areas were much warmer than that. We also know that January through August were the warmest individual months on record for those months, which concluded a run of 17 in a row over that time period, going back into 2015. September, October, November, and December were all very warm months too. They were in the top three of their respective months. One thing that this map here does not show, but I think is very important, and we'll talk about it a little bit more here, is that the Arctic saw its warmest year ever this past year, and that is, I think, contributing to a lot of what we're seeing, of course, in the mid-latitudes. So we'll come back and we'll talk a little bit more about that in a minute. If we drill down from the global view to the U.S., these are what are called statewide average temperature ranks. So it ranks each state based upon whether it was record coldest, number one, up to the record warmest, 122. And you can see pretty much everybody was either in a top 2, 3, or 4 of being the warmest temperatures in the January through December record for 2016. The continental United States itself, 2.9 degrees Fahrenheit above average. It was the second warmest overall in the record, and the 20th consecutive year we've had above average. Now, if you go from average temperatures to maximum temperatures, you see this, the signal is virtually the same. A little bit of difference in terms of the absolute magnitudes, but most everybody was above average or much above average in terms of maximum temperatures over the year. We can also look at minimum temperatures. Minimum temperatures a little bit different. There's 6 states that had their warmest minimum temperatures across the year, but everybody again was still in a kind of a top 3 for the much above average. So we had our warmest nighttime temperatures in this 122-year period of record. If we drill down into California, I've just taken and plotted out here temperatures during, more or less the growing season in April through October. And this record would look a little bit different if we looked at the entire year, but you can see the basic year-to-year variation and kind of what that trend looks like. Over 1895 to 2016, this entire average for California is warmed by 2.3 degrees Fahrenheit. However, there are some slight differences between some of the climate regions within California, ranging anywhere from 1.5 degrees to almost 3.2 degrees warming in some of the different areas over this same time period. So you can see there's some variations within the state. We can also look at the growing season temperature distributions over time, and we can see that looking since 1995, we've had 3 years that have been below the average, and the last one was 2011. But you can look at 2010 was 1.6 standard deviations below our long-term average, while you can look at 2016 being 2.6 standard deviations above the long-term average. 2015 was just slightly higher than that. Going to precipitation at the national level, you can see a lot of variation in the amount that was received across some of the climate divisions. For the United States as a whole, we were above average, 24th wettest in the 122-year period of record. There are some drought zones that developed in 2016 outside of California, parts of the southeast, and you can see there in it, the Piedmont of Georgia, Mississippi, and the Carolinas, and then also up into New England. But other areas also declined, where you can see parts of the West that has been dry has now had, 2016 with near average to above average rainfall. We also have this measure in climate studies called Climate Extremes Index. It looks at multiple different measures to try to put it in perspective of how extreme the weather is in any given year or any given region. And this is the data for 2016, and you can see that the vast majority of the country was much above average. What we saw this past year, like in 2015 as well, we saw extreme maximum and minimum temperature variations and also extreme one-day precipitation totals that were quite a bit above average. For the western United States, both what's called the West and the Northwest in total, we also had elevated extremes in maximum and minimum temperatures. However, our drought extent declined, which basically produced a situation in which we saw declines in extremes overall from 2015, but they're still much higher than average than what we've seen historically. Now, going to just summarizing this to the major West Coast influences in 2016. El Nino, of course, a lot of people have called it a dud. I just basically in this really had a minimal effect, mostly through precipitation. Didn't receive what we thought we might receive. So we had little winter into spring influence there, I think. The biggest piece that it really did for our climate was it gave us an extremely warm winter and carried that warmth into the spring. So the massive warm water in the tropics was really all about supporting warmer temperatures. The big difference in 2016 was the North Pacific cooled down dramatically. This actually happened in mid to late June and carried into July. And it really moderated temperatures for the rest of the growing season and into the fall. And it produced one of the coolest Julys we've seen in a long time, much more so in the Pacific Northwest, but also throughout the West overall. This also led to a fairly wet October. And as in hindsight, as I look back to it, I really see this as the June-July cool down in sea surface temperatures in the North Pacific being the precursor to kind of what is driving what we're seeing right now in terms of climates throughout the winter season. So if we go from that, looking at 2016 and go to current conditions, I want to start with the sea surface temperatures because I think this is a really important aspect of it. And there's three different things to look at here. One is across the tropical bounds where the El Nino, La Nina kind of framework is typically measured. You can see that there's areas in here in the central tropics where there are, in the Pacific, where there is colder than normal conditions. However, this is considered to be a fairly weak La Nina, and it's actually already considered to be waning right now. The big thing that I think that is happening up here is across two 20-degree bands from roughly 20 degrees to 40 degrees north latitude, there's an area in which the water temperatures are relatively warm. And then just north of that, there's an area from 40 to 60 degrees of latitude in which water temperatures are quite cold. In the past few years, this big area of cold water was much more confined to a smaller area out over toward the central North Pacific. This is the first time in maybe 5 years that this amount of cold water is extended this far toward the western part of North America. And I think that part of our situation currently right now, and even driving into our growing season coming up, is largely going to be driven by what we're seeing here in the North Pacific. And I'll talk about that a little bit more here in a minute. Are we having a typical La Nina winter? If we looked at the data from as much information as we have, La Nina winters tend to be cold and wet in the Pacific Northwest. They tend to be cool and near normal precipitation to slightly drier than normal in the California, Nevada, and even into the desert Southwest. Everything in between is kind of a transition. Some years it moves a little further north, some years moves a little further south. When we look at one of the major things that is happening right now, and I know you guys have been living this, and it's been in the news, people talking about atmospheric rivers. I just wanted everybody to know that these are relatively common factors of the atmospheric circulation that we have globally. However, we've had the conditions that have been very prominent this year to make them more influential in our West Coast weather. Namely, the dynamics that you really need to have all this happen is this very vigorous trough, low pressure area that stays in place out over the Pacific and Western U.S. Then you also have to have all this moisture showing up in the tropical bounds, and it's the vigorous nature of these low pressure areas that pulls that moisture up. And if these troughs stay in place long enough, then we can end up having these prolonged heavy rain events. What's different this year compared to years past is the trough areas are deeper south, and so these atmospheric rivers have been more inclined to affect California than they would, like they normally do, Oregon, Washington, and British Columbia. But I also want to note here that if you look at this, this is a map of the same time period. I just want you to get an idea that these atmospheric rivers do occur. It's just that their longevity, frequency, and severity of amount of rain, snow that they can bring depends on that trough type of low pressure events that we have in the Pacific now. So if we looked at the temperature patterns, this is going from October 1st to January 15th. The temperature patterns in the West are close to what we might expect from a weak La Nina. Fairly cold up in the Pacific Northwest and Northern Rockies. A little bit warmer than we might expect in kind of central to Southern California, and quite a bit warmer than we would expect in places in the Four Corners and Desert Southwest. From a precipitation standpoint over the same period, it's much greater than what we would have expected from a weak La Nina. And I think that because of that cold dynamic troughing and things going on in the North Pacific, I think it's definitely been a wetter year than we would have expected. It's definitely more widespread with areas from 110 to 300% of normal rainfall to date. You've probably seen this in some of the news outlets down there. This is the 8-station Northern Sierra Index from the California Department of Water Resources. And if you look at it as of January 9th, we were on track to be wetter than the wettest year that we have during this data record, which was 1982-83. However, we still got a long way to go to make it there. And I think this second half of the winter will likely push us somewhere in between here. I wouldn't expect it to end up being the wettest year, but there's still a lot of winter left to go. If you switch from just simply rainfall to snow water equivalents in the mountain, because that's what we need for summer runoff, you can see that everywhere in blue here across the West is areas in which we have greater than normal snow water equivalents, anywhere from 100 to nearly 200% of normal in many places. However, parts of the Northern Rockies, even though it's been quite cold there this winter, and even down in the desert Southwest, have lower than normal snowpacks, and there's really still a long way to go until the snow water season is over. So everybody's probably gotten sick and tired of hearing of information from the drought monitor of the past 5 years, but this is the most recent drought monitor from January 2010, and there's still some drought zones up in the Northeast, down in the Southeast, and of course in California. But when you look at California from last January to this January, what a difference a year makes overall. You can see that the overall extent has gone down. There's a 30% reduction in some of the more severe areas throughout the West. And then California has seen a 38% reduction over this time period, and even a 41% reduction in the overall area that's been defined as being the most extreme. So all of this rain and snow that we've had this winter has been good. The question is, how long will it last, and will it get rid of this entire drought zone? California reservoirs, this is some current data, and again, you probably see this from the California Department of Water Resources. The current capacity averages 64% of all of these reservoirs, which is really good at this time of year. It's also at 106% of the historical group average for this time of year. So we're in pretty good shape overall. However, rain inputs and more snowpack is needed to continue this, because if we transition into a dry spring, some of this will disappear pretty quickly. So taking that all into kind of some summary and forecast information, first thing is that we've really in the West have gone from drought to deluge. It's pretty clear. But if you look back in the historical data, the Western U.S. is prone to this kind of thing. We don't tend to flip from drought to a lot of rain really gradually and easily. It tends to come pretty quickly. So we should expect that to be the case and even happen as much in the future. I would expect, without El Nino occurring in the tropical Pacific, when we get to neutral conditions, that 2017 will be cooler than 2015 and 16, and likely to kind of the average of what we saw between 2010 and 2014. The long lead forecasts coming out of some of the Met agencies worldwide, this one's from the Met Office, is showing that 2017 is likely to end up really close to where we were globally in the past few years, but it'll be a little bit less than what we saw in 2015 and 16. We should expect weather and climate extremes to continue to be near record numbers. There's no evidence that any of that is going to change quickly. We have the same kind of signal in the Pacific Northwest and the West, so I wouldn't expect them to be much different either. The spatial extent of drought in the U.S. overall has declined. The overall footprint of drought has gotten smaller. It's likely to continue. Most of the forecasts are saying so. I'll show you a map here in a minute that kind of indicates that. A warming Arctic, and when I mean warming, there were some times earlier this year that entire 2, 3, 4 week periods in the Arctic were 40 degrees Fahrenheit above average. So very extreme, much warmer than normal conditions in the Arctic. And we think that this is producing some very strong mid-latitude variability. There was a point in November or December in which Siberia was 40 degrees below average, where the Arctic was 40 degrees above average. So some real displacement of these cold air outbreaks, and we think they're somewhat connected. We also know that there's this larger normal area of North Pacific that is cooled, and it's likely to favor a cooler year for the U.S. as a entire area. If we go to the general forecasts that are out there from NOAA's February, March, April forecast, it's basically showing that the north is expected to be colder than normal, the south is supposed to be warmer than normal, and that there's an equal chance in between. And a lot of this is being based upon how rapidly the La Nina will transition and how much influence the North Pacific has. However, if you look out even further into the long lead forecast for March, April, May, June, July, August, it shows that the probability increases for a warmer Western U.S. Rainfall-wise, same time period, February, March, April, the precipitation forecast is tilting the odds toward a slightly wetter, drier, kind of average spring throughout the West. That EC on the map there means it's an equal chance. I take that as saying that there's no real clear driving mechanism that will keep us staying as wet as we are right now through the rest of the spring. And then March, April, May, and beyond, it's projected to get drier throughout the West. This is the seasonal outlook for the drought monitor. There's an update coming out tomorrow. And basically what this one is showing us, I think, will change a little bit as many of the areas in the New England region, Southeast, and California will likely show more green and areas that will likely have a drought removal come up over the next 3 months to 4 months. A lot of it depends on really, again, how much rainfall we get the rest of the winter in the West. So if we take all of this and bring it down to spring and summer forecast, this is what I'm seeing out there. The basics are for the western U.S. overall. Tropic conditions, surface temperatures are going to transition. They are already calling it to happen by late spring, early summer. The North Pacific is likely to remain colder than normal. This could be more of a long-term kind of thing than short-term as well. Taken together, if you just look at all of the historical perspective behind this, this would tilt the odds for California to have a cool and drier late winter, early spring, and for the Pacific Northwest to have a cool and wet late winter or early spring. Statistically, if you look at the data, spring frost frequency and severity does tend to be higher in years with these conditions. It doesn't mean you can predict it to happen in every individual location. It just means the tendency is to be more frequent and more severe. We also tend to have growing seasons that are on the cool side. I don't mean real cold, but what I mean is that they tend to be slightly cooler, more close to average, with lower heat stress whenever we have years like this. And lastly, I think that drought relief in California will slow a little bit. I'm not sure we're going to continue the rate of replenishment that we're having right now. However, long term, for complete recovery, we need 3, 4 or more winters like this to really recharge the groundwater systems and get us back into a place where we're not being challenged the way we have been. So with that, I thank you very much, and I think Thibaut's got a way in which we can do questions if anybody would like.
Yes. So thank you, Greg. I don't know, can you hear me?
Yes, I can.
Okay, so I'm looking at the Slido, and right now I see no questions being written, but maybe somebody has a question verbally. I'm looking at the attendees. Yes, can you please give the microphone to Joachim? One question is coming.
Yeah. So, Dr. Jones, if we could compare what could be 2017 to one of our historic years, could you give us that year?
Yeah, that's the $1 million question. But, I think if I were to put a bookend on it, I think it would be much more like 2012 and 13 than 14, 15, or 16. The colder spring is likely. How much rainfall, snow we get between now and then is probably the big question. But I do think we're going to have a colder spring and a slightly cooler growing season.
Any other questions? Okay, Greg, it seems like no other questions are here. Thank you so much. It's always feel like talking to a magician when we listen to your prediction, and often it's very, very, very enlightening. So thanks a lot, Greg. I wish you the best. Everyone is clapping hands.
Thank you very much. I appreciate it.